Imagine an internet where you aren't just a product being harvested for data, but an active participant in an open system. Welcome to This Explainer. Today, we're going on a pretty wild journey. We are going to trace the exact architecture of our digital economy, starting from the very first basic web pages all the way to massive autonomous AI agents and decentralized ledgers. If you've ever felt like you're losing control of your digital footprint, or you're just wondering how we went from simple chat rooms to AI making stock trades completely on its own, well, you are exactly in the right place. Let's dive in. I want to kick things off with this striking quote from the sci-fi writer William Gibson regarding the early internet. He said, "The net is a waste of time, and that is exactly what is right about it." It really reminds us of a simpler time, doesn't it? Honestly, that quote hasn't exactly aged well. We now live in an era of hyper-optimized algorithms, complex data economies, and artificial intelligence predicting our next financial moves. But it perfectly highlights just how much things have changed. So here is our roadmap for today. We're going to track the evolution of the internet, explore the modern data economy, unpack the sudden rise of AI foundation models, look at the real economic impact of those models, and finally, examine blockchain as a potential decentralized alternative. Let's jump right into Section 1. The evolution of the internet. We need to look back at how the web's architecture rapidly developed over just a few short decades. It's actually staggering how fast this happened. Our journey kicks off around 1990 with the creation of the World Wide Web. By 1998, major search engines like Google had emerged to organize it all. Then a massive paradigm shift happened in 2009 when Bitcoin introduced blockchain technology to the world. And that brings us to the present day, the era of artificial intelligence. The speed at which this infrastructure has compounded is just incredible. But the crucial point here isn't just the tech. It's how our relationship with the network fundamentally changed. The early web, it was strictly read-only. You went online just to consume static information, like reading a digital magazine. But then came the shift to collaboration. We saw weblogs, or blogs, where users started generating their own content. Social networks emerged, building massive virtual communities. And wikis introduced peer production, where literally anyone could edit and contribute. The big takeaway? We stopped just reading the web, and we started building it together. Which brings us to Section 2, the data economy. Because all of that constant massive user interaction we just talked about, it gave birth to the defining economic engine of our century. To really grasp this, think about a classic industrial factory. The owner of the capital owns the physical goods produced by the worker, right? The worker just gets a wage. Now compare that to a modern digital platform. You, the user, produce raw digital data just by interacting, posting, and searching. You are essentially the worker on the digital assembly line. But it's the platform that owns that data, processing it through their massive infrastructure to make it incredibly valuable. And depending on where that data is generated, we see two totally diverging models today. On one hand, data can act as a collaborative public good. Think of open source projects or Wikipedia, which aim for a shared societal benefit. On the other hand, we have proprietary data. Here, the data you generate on commercial social networks or search engines becomes a highly lucrative asset for a corporation. This is often referred to as surveillance capitalism, where extracting your data forms the absolute core of the business model. So how do these proprietary platforms grow so massively? Through incredibly powerful platform dynamics. First, you've got network effects, meaning the more people that join a platform, the more valuable it becomes for everyone else. To accelerate this, platforms use cross-subsidies. They hand you incredibly complex, amazing software literally for free just to attract billions of users. But there is a hidden exchange taking place. You are effectively paying for these free services with your personal data, giving these companies the exact raw material they need to thrive. Now let's move to Section 3 and see how this data explosion builds into our current technological paradigm, the breathtaking rise of foundation models in artificial intelligence. All of that proprietary data we just discussed, it doesn't just sit in a server farm gathering dust somewhere. It is the vital, raw fuel for machine learning. Tech giants are taking oceans of disparate data and flowing it directly into highly structured artificial neural networks. And this brings us to foundation models. What exactly are they? Well, unlike older, narrow algorithms designed to do just one specific thing, foundation models are highly scalable AI systems pre-trained on massive datasets. They possess broad applicability. They can generate text, write code, create images, you name it. Crucially, they use positive feedback loops to continuously self-improve. And here's the crazy part. Their performance actually scales up the larger you make their computing dimensions. The bigger they get, the smarter they get. Let's look under the hood for a second. These models combine your physical, digital, and financial footprints. They chop this information into tokens, think of them as tiny digital puzzle pieces, and use what are called attention heads to weigh which pieces are most important in any given context. By measuring high-frequency behaviors like exactly how many milliseconds you linger on a post, the AI constantly adapts to predict what you'll do next. And this is where it gets truly wild, because this isn't just academic theory anymore. We are already seeing specialized AI agents operating in the real world right now. We have trading agents, which are multi-agent frameworks simulating real-world firms to execute livestock trades. There's Kronos, a foundation model specialized purely for financial markets. We even have tools like OpenDevin, autonomous agents that can literally write software code and browse the web completely on their own, or platforms using automated webhooks to trigger real-time actions. This tech is moving fast. Which leads us perfectly into Section 4, AI's economic impact. Because when machines can perform these highly complex cognitive tasks autonomously, we have to talk about the profound macroeconomic shifts that follow. This autonomous power forces a massive shift in the very foundations of our economy. First, we see factor reallocation. As cognitive tasks are automated, workers will need to transition across entirely different sectors, making large-scale retraining absolutely essential. Second, the capital share of the economy rises. This is huge. It means as automated goods make up more of our GDP, the owners of the capital, the AI and the servers, capture more value relative to human labor. Finally, corporate delegation. Because AI drastically reduces the cost of monitoring complex systems, firms can actually decentralize their authority, fundamentally changing how corporations are run. But, as you might guess, with these massive shifts come significant governance and market risks. For instance, if firms use algorithmic pricing, there's a real risk of autonomous collusion, where AIs quietly raise prices together without any explicit human direction. And think about the legal nightmare here. If an autonomous agent makes a harmful decision, who is legally responsible? The developer? The user? To manage this, policymakers are desperately focusing on steering the underlying computing power, or compute, and establishing global auditing frameworks to ensure AI is developed safely. So with all that centralized power in mind, we arrive at Section 5. Decentralization and blockchain. Is there a viable alternative to these giant tech monopolies controlling all our data and running these massive AI models? This is exactly where blockchain technology enters the picture. Let's define it clearly. A blockchain is a distributed, decentralized public ledger. Instead of a central bank or a tech giant validating your data, transactions are recorded transparently and validated by a wide network of participants. It offers a completely different architecture for the internet. It distributes trust across a network rather than centralizing it into a single corporate silo. Let's look at how this actually works in practice with a standard Bitcoin transaction, just to make it concrete. Step 1, user A decides to send a certain amount of Bitcoin to user B. Step 2, that transaction request is broadcast to a network of computers, known as miners. Step 3, these miners use intense cryptographic processing to validate that user A actually has the funds to send. Step 4, once validated, the transaction is permanently locked into the next block on the chain. And finally, Step 5, the entire distributed ledger updates globally for everyone. This step-by-step process proves that a decentralized network can securely move value without ever needing a traditional bank or middleman. As we wrap up this explainer, I want to leave you with this final pivotal question. On one hand, the incredible power of AI foundation models demands massive centralized data sets and enormous computing power. But on the other hand, blockchain technologies offer us a working blueprint for decentralized ownership, trust, and peer-to-peer exchange. So, will AI ultimately centralize our digital future into the hands of a few tech giants? Or will decentralization rewrite the rules of the entire economy? It's the biggest question of our time. Thank you so much for joining me, and keep questioning the architecture of the digital world around you.